All right, lesson 6 is the first lesson in the next topic, topic B, where we're going to focus on solving radical equations. So we're going to start with square root equations. And to introduce that, we're going to kind of go back and talk about quadratic equations that we solved by taking the square root. So what we're going to do is we're going to find these solutions mentally by taking the square root of both sides. So if we take the square root of both sides, we talked about how the square root and the second power cancel, and the square root of 4 is 2. But because we're solving and we're taking the square roots to solve, we have to be mindful of another solution. So we all know that the square root of 4 is 2, because 2 squared gives you 4. But because we are solving, x could also be negative 2, because negative 2 squared also gives us 4. So what we got to think about is, what number can I substitute in for x that when I square it, I get 4? Well, that'll be 2 and negative 2. So we write it as x equals plus or minus 2, or x equals 2 and x equals negative 2. Now, same idea here. If we square root both sides, now the square root of 2 is not a whole number, so we're going to leave it as x equals plus or minus the square root of 2. So we have two solutions, positive square root of 2 and negative square root of 2. Now, number 3, we have x squared equals 0. Again, well, if we think about what number times itself will give us 0, that's got to be 0. Or we could square root both sides, and again, the square root of 0 is just 0. Now, number 4 is where it gets a little bit tricky, because you say, oh, let's square root both sides. And say, okay, let's take the square root of negative 1. Oh, it says no error, non-real answer. And we'll talk more about what that means later on. But there's no real solution to this. Because again, if you think about it, if I square a number, if I take any number and I raise it to the second power, like 3.5 to the second power, I get a positive number. If I do any negative number, negative 1.45, and raise that to the second power, I get a positive number. So no matter what number I raise to the second power or square, it's always going to be positive. So there's no number that I can square and get a negative answer. So this is no solution right now. And I want to kind of write that down, that when raising any number to the second power, the result will always be positive. No matter what number we raise to the second power, it will always be a positive result. So there's no solution to this x squared equals negative 1. So on the next page here, it says Claire was adding the square root of 4 and the square root of 9. And at first she wrote, the square root of 4 plus square root of 9 equals 2 plus 3, because the square root of 4 is 2 and the square root of 9 is 3. But then she remembered that 2 and negative 2 both square or raise to the second power to make 4, and 3 and negative 3, you can square each of those and get 9. So she wrote down all these combinations where, they're both positive, we get 5. If we do negative 3, 2 plus negative 3 is negative 1. Negative 2 plus 3 is 1. And negative 2 plus negative 3 is negative 5. So which one is it? Are all of them true? Some of them true? One of them true? So to answer this question, which one is the same, which one is correct, or all of them correct, when we take the square root of a number, again, that is the 1/2 power. So 4 to the 1/2 power And we talked about this the other day, that if I have a number, a positive number, raised to any power, my answer is going to be positive. 4 to the second power is 16. 4 to the 1/2 power is 2. So there's only one correct answer when we are given the square root. So when the square root is already written, there is only one answer. So again, like up here, the reason why we had to do plus or minus is because we had to write in these square root symbols to solve. We wrote them in for this problem. Here, the square root symbol is already written in, so there's only one solution or one answer for that. Let's write that in. When you write the square root symbol, square root, to solve, you must have plus or minus. And I know we wrote this somewhere else in our workbook, but I wanted to have it here as well. Repetition will help you remember it more. Now we're going to skip the are you ready for more and talk about this situation here. So we have a function, and we're going to represent it with a table and then draw a graph of it. So we have x is 0, 1, 4, 9, 16, 25, and 36. And now the square root of x. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. Square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. And the square root of 36 is 6. So let's graph this. So 0, 0, 1, comma 1. And look at, each tick mark is kind of like 0.5 in the y direction, or 0.25, 0.5 in the y direction. And in the x direction, they're all ones. So then we have 4, comma 2, 9, comma 3, 16, comma 4, 25, comma 5, and 36, comma 6. So we have this. Now, when we look at this, I want you to notice that there are no negative y values. We can't take the square root of a number and get a negative answer. So I want us to write that here. Can't take the square root of a negative number and get an answer. And we saw that. We tried to take the square root of negative 1. The calculator gave us an error. So that's why you don't see any any negative y values in this graph. So is this a function? Yes, this is a function because it passes a vertical line test. A vertical line test says, hey, if I drop a vertical line and if I only touch the function once, no matter where I draw this vertical line, then this is a function. Whereas if I drew a vertical line and touched it twice, like let's say this graph went like this as well, this vertical line could touch here and here. So then that wouldn't be a function. But because this passes the vertical line test, this is a function. So the graph passes the vertical line test. Now, explain how you could use the graph to find any solution to the equation the square root of x equals 5. So we would find the intersection point, find the intersection point of y equals the square root of x and y equals 5. So up here, here would be y equals 5. If we draw this, this line here is y equals 5. The other line here, this is the square root of x. So where they intersect, that would be the solution. So they intersect at 25. So there's one solution, and that would be at x equals 25. It didn't ask us to tell us the solution, but I want us to kind of get that idea of, all right, we have this equation, and what we can do is we can graph each side and then see where they intersect. We graph the left side and we graph the right side, and then wherever they touch, that is their solution. Now, use the graph to approximate the value of the square root of negative 5. So remember, this is the square root of x, so here's 5. If we go up, it touches right there, so it's a little above 2, but below 2.5, so maybe 2.2. About 2.2. Explain your reasoning. So we find x equals 5 on the x-axis, then follow the grid line up to where the function square root of x intersects. So we drew a line up from y equals 5, or we drew a line from x equals 5, it heads right about there, and that was our y value. Okay, so approximate any solutions to the equation x squared equals 20. So now, again, we are solving. Here, it was just, hey, what is the square root of 5? The square root was already given to us. To solve this, we would actually have to draw it in, so we would have two solutions. So here's 20, and we're going to do the same thing. Go up. So it's a little above 4.5. Maybe 4.6, around there. So it's about plus or minus 4.6. And the reason why it's plus or minus is because we are solving for x. There could be more than one solution. Whereas if I just asked you, what is the square root of 20, you would do that like we did number 5. But because we're asking to find a solution, we would say plus or minus a value. Okay? So now, here's our lesson summary, and we've already kind of talked about this, so it's important to highlight this as well in here to reinforce that. If we have just the square root of a number, that is a single positive number. There is one solution. Now, if we have an equation x squared equals a, then there are two values, this, positive square root of a and negative square root of a, that will give us that solution. So again, if you have the equation x squared equals 11, there are two numbers that when we square, we get 11. Positive square root of 11 and negative square root of 11. So notice this is not the square root of negative 11. That's a big pile of no. Now here the equation x squared equals 11 only has one solution because the square root is already written. Okay? And it's 121 because if we were to square both sides, we would just get 121 is equal to x. It's one solution. And then, like we talked about, the square root of a number can't equal a negative value, so it has no solution because we can't square a number, raise a number to a second power, and get a negative result. No solutions. Okay. So we're going to explore this idea more in the next few lessons, but it was just kind of a good foundation to understand, in what situations do we have a plus or minus solution, a positive and negative solution, and what situations where we just have one solution or a positive solution. So we're going to explore this a little bit more later on. So thanks for watching. Make sure to like the video and subscribe.